Hello students, we are meeting for our next lecture of environmental chemistry, and today we are going to start the last chapter or last topic, which is a small topic. So within one video we can complete, and I have shared the reading material from the book on Google Classroom, so you can read that, and you can refer the reference books also. So today we'll start the green chemistry and hazardous organic solvent by Professor Nandukar. Now, first we'll start with the introduction that why these separately hazardous organic solvents are discussed in this chapter. Why is it so important? So whenever we are carrying out any reaction, especially organic reaction, these reaction require various components. What are those requirements? The first one is the reactant that were discussed in detail as a feedstock. Then we need catalyst, we need reagents, we need a source of energy, and then we need uh, the solvent. That is very important. Okay, so all these things are very important. In some reactions, maybe catalyst may or may not required, or sometimes you may or may not need to supply energy. But solvent is necessary in most of the reactions. I'm not saying that all reactions require solvent, but in most of the reactions, solvent is necessary as far as organic chemistry reactions are considered. Now, why is it so that solvent is necessary? The reason for this is that most of the organic solvents, they are not soluble in the eco-friendly solvents such as water, because most of the organic compounds, they are non-polar or less polar, so they are readily soluble in organic solvents. And organic liquids are also required for the extraction of final product. When the reaction is completed, suppose your product is soluble in the reaction mixture itself, then you have to extract, or sometimes multiple products are formed, or sometimes byproducts are formed. So all these are to be separated from the desired product, and for that also you need organic solvent. Now, use of large quantity of these solvents is a matter of concern. Okay, because these organic solvents, they are toxic to human being. They are toxic to the people who are working or continuously exposed in industry, and releasing them in environment also, they are very threatening to the society also. Okay, it's not only the human being, but to the all living things, they are very threatening or problematic. Now, what are those problems? First of all, the toxicity. Okay, then maximum, or you can say most, all of the organic solvents, they are carcinogenic. So that is a very serious thing. And very important thing is that they are non biodegradable. Okay, so disposal and recycling is very expensive. You need to set up a separate unit for proper disposal of the organic solvent. So what are those solvents which are very problematic or very threatening or toxic to the environment? And among these, very common is benzene, toluene, chlorinated or polychlorinated solvents like chloroform, carbon tetrachloride, or DCM, you can say dichloromethane, and even solvents like DMSO, dimethyl sulfoxide, DMF, dimethyl formamide, or petroleum ether, they all come under the category of toxic and hazardous solvent. Okay, so they are used in industry or laboratory in large quantity. So these solvents used in laboratories or industries along with hazardous byproduct produced during different manufacturing processes, and it creates the large burden on the environment. So to reduce this burden on environment, the industries and laboratories are required to work on some of the points. What are those? First, can you think about the replacement of these hazardous solvent? So you have to replace it by non-hazardous solvent. And another point is that can you go for research or development of novel methods or techniques where you can bring about the no solvent free synthesis. Okay, so where such no need of such solvent. So you have to think about both the points. So in book they have given various solvents, their toxicity and their hazardous nature on this scale of 1 to 10. So higher the number, higher is the threat. Okay. So uh, all the harmful level they are expressed in terms of number. So you can go through the reading material which I have provided, and you can go through that table. So there are in various representative uh, solvents are given. Okay. So, how can we overcome this problem? Okay, so green solvents. What are the green solvents? How these green solvents are more useful than the organic solvents, and how they can provide the alternative method? In that, first is ionic fluids. What are these ionic fluids? Ionic fluids or ionic solvents are the liquids are these are the liquids of mixtures of anions and cations. For example, molten salts means if you heat the NaCl, you will get NaCl in molten form. So that becomes the ionic solvent. Okay. So the examples are here like N-alkyl pyridinium salt, where it is ionic as well as organic. So you can dissolve the organic reactants in this solution or solvent, sorry, or you can use N-dialkyl imidazolium salt. So these are non-volatile, non-coordinating, but polar, immiscible with many organic solvents. So these are commonly are alkyl ammonium salts that just now I have given the example. So these non-volatile ionic liquids can be easily recovered after use. That is very important because to make it to in the liquid state or in the molten state, you have to heat. So when you cool, you will get solid separated. They can be recovered and purified. That is very important. The product can be isolated from ionic solids by using some common solvent like ether. Okay, so this is the application of this. So there are two types of ionic liquids. One is protic ionic liquid and aprotic. Protic means all of you know when there is a release of H plus ions, that is a protic ionic liquid, and aprotic. So depending on the requirement, you can use the different types of these ionic liquids. Then next solution to this problem is water-based chemistry. Means water is considered as problem for organic synthesis. Why is it so? Because water is polar and organic compounds are non-polar. So they are less soluble in water. So also the purification and drying of final product is also a problem. Okay. So Nowadays, water-based organic reactions have become popular. Okay, so people are thinking, can we use water-based kind of research? So it is a very non-toxic, cheap, or biorenewable, non-inflammable, and has high specific heat capacity. That these are the, you can say, features of water as solvent. So that's why water is called as universal solvent. Okay, and in some of the reactions, it is found that use of water increases the rate of reaction. Okay, the example is Diels-Alder reaction. Okay, here Diels-Alder reaction, you can see here cyclopentadiene reacted with this alpha beta unsaturated ketone. Now here cycloaddition kind of reaction is taking place, means Diels-Alder 4 plus 2. So you some of you may not know this reaction. So here only thing I want to mention here is that due to this hydrophobic property of some reagent makes water an ideal solvent. So if this reaction is carried out in organic solvent like octane, the rate of reaction is 1. Okay, if you carry out in methanol, then 12.5. If you carry it out in water, then it is increased to 740 times than octane. If you are using ionic liquids such as LiCl, then it reaches to 1800 times faster. So use sometimes use of these water based solvents are there very important. So you have the new researchers have to think about this, that can we develop such water based chemistry. This can be a one solution. The next is fluorous biphasic liquids, which are also called as fluorinated phases. So in this s- method, fully fluorinated solvents such as C6F14, means this is a completely fluorinated hexane. Okay, all hydrogens are replaced by fluorine. Are non-polar immiscible with organic solvents. So these solvents are non-polar and they are immiscible with organic solvent. These can be easily dissolved, used to dissolve catalysts with long perfluorinated chain. So those catalysts are very effective and provide high yields in reactions where catalyst plays a important role. So these are also one can say solution to the our problem. The next is supercritical liquids. Why these are called? What are these supercritical liquids? Supercritical liquids like supercritical carbon dioxide or supercritical water. These liquids are those which in which above their temperature is above critical temperature. Okay, and pressure have densities of liquids but viscosities of gases, means at the time it can behave like a liquid as well as gas. That is the uh, main feature of this supercritical liquid. So they can diffuse through solid like gas and dissolve material like liquid, means at a time they can go through or diffuse through the solid like gas. So gases diffuse very fast, but at the same time they can dissolve the uh, your reactant like a liquid. So close to the critical point, small changes in temperature or pressure result in large changes in density. So you can control that, these parameters, and by changing that they will allow their properties to be fine tuned. So they are considered as good substitutes for organic solvents in a number of industrial and laboratory processes. Okay. So here carbon dioxide and water are most commonly used supercritical liquids. So what are the advantages of these supercritical liquids? that if you decrease the pressure, it leads to release of gas. Means if you decrease the pressure, they will convert it to the liquids. So they can be easily separated. That is very important after the reaction is over. Means it can be recycled many times. So this, for example, if we are using supercritical carbon dioxide, so it can be used for extraction of caffeine, or you can use it for dry cleaning or spray painting. One of the example is carbonic esters, dimethyl acetate. So dimethyl acetate or dimethyl carbonate can also be used in this as a, you can say, supercritical liquid. Now, last point is regarding the can we go for solvent-free reactions? Okay, and if you want to go for solvent-free reaction, you have to use green catalyst. Okay, now what are those green catalysts? That is fluorinated silica aluminum catalyst in production of linear alkyl benzene instead of HF catalyst. Or you can use zeolites, you can use titanium oxide as a photocatalyst, or biocatalyst as enzymes. So there are various ways, and there are alternative techniques also. What are those? Can you use microwave directly, so that you can replace the solvent completely? And directly you use of microwave or sonochemistry, means where you can say sound waves are used. So microwave sound waves, if they are directly allowed to expose these our reactants to these waves, the reaction can be carried out without use of solvent. That is called as solvent free reaction. So can we develop like that solvent free synthesis? And there is one more alternative technique, that is, can we get the solvents from plants? Means hazardous organic solvents, they can be replaced by eco-friendly clean solvents like water, polyethylene glycol, ionic liquids, or some other members. And from plants you can extract plant oil. Okay, so they can also be used. So vegetable oils, they can also replace petroleum derived organic solvents. So this is one more you can say solution to the problem of organic hazardous organic solvent. So this is a very small chapter and very small topic. And with this, our three chapters that we are supposed to discuss, that we have finished. The first is introduction to green chemistry, then introduction to green chemistry and technology for sustainable development, and last one is green chemistry and hazardous organic. So these are the three topics that were supposed to finish, that was finished within the time. And I have provided you with the reading material also. You can watch these videos later on also if you find it necessary, and you can prepare. Still, if you have any problem, as I mentioned in earlier videos also, you can um, uh, post your queries or problems or difficulties on Google Classroom platform, where I will entertain all your doubts and difficulties, and if I find it necessary, we can conduct online lecture. For time being, we'll stop here. Thank you.